So a slope of a line is the steepness of a line, the ratio of rise to run, or the vertical change to horizontal change. We can also think of it as rate of change for dealing with word problems. That's the difference between two outputs, so two y values, divided by the difference between the corresponding inputs or x values. So again, just think about two different points. For linear relationships, the rate of change is constant. Again, we can find the slope or the rate of change algebraically. We can use the following. So n is a variable that we use for slope, is equal to y2 minus y1 over x2 minus x1, where x1, y1, and x2, y2 are points on the line. We can also find it graphically by using rise over run. Okay? Remember, lines that rise from left to right are positive. Lines that fall from left to right are negative. Then we've also got two special lines. So a line is horizontal, its slope is 0. And if a line is vertical, its slope is undefined. Okay. And it's not a function either. So with all that in mind, let's work some of these out. So we got A. We've got the point 2, negative 1, and the point 3, 2. So we can find the slope of these 2 points, or the slope of the line between these 2 points, by saying, here's my x1, here's my y1, x2, y2. So we can plug it into our slope formula. So y2, which is 2, minus y1, which is 1, divided by x2, 3, minus x1, which is 2. Now remember, when you subtract a negative number, you can really think of it as we have a negative times a negative, it's going to give us a positive 1. So 2 plus 1 gives us 3, 3 minus 2 gives us 1, 3 divided by 1, we have a slope of 3. And again, we can think about it, we're going up 3 units, and we're moving to the right 1 unit. Okay? So 3 is still 3 over 1. Okay? Let's look at B. We have negative 1 and 2, and 1, 1. So those are our 2 points. So how can we set that up?
You gotta do y2 minus y1.
So y2 minus y1, so 1
minus
1 minus 2.
Oh, 1 minus 2. And then you'll do, hold on, x1. And then you'll do 1 minus negative
1 minus 1 negative. Perfect. So 1 minus 2
is negative 1.
gives us negative 1, and 1 minus a negative, or 1 plus 1
Is 2.
is 2. We can't reduce that, we can't simplify it, so just negative 1/2. So that means we have a negative slope, or downhill. And then we have C. So here's our special cases. We've got the point negative 4, 8, and the point negative 4, 4.
4 minus 8.
4 minus 8.
And then negative 4 minus negative 4.
So that is going to get us 4 minus 8 is negative 4. Negative 4 minus a negative 4, or plus 4, it's a 0. And we cannot divide by 0. Okay, that's just one of the math rules. Can't divide by 0. That is our undefined line. Okay. Our slope is undefined.
So the answer is undefined.
And then our last one, D. We've got 5 and negative 7. For our first point, and negative 2, negative 7 for our second point. So y2 minus y1
-7 minus -7.
over,
-2 minus 5.
that is gonna get us -7 minus a negative or +7. It's a 0, -2 minus 5 gets us a -7.
That's undefined.
So this one's not undefined. We can't divide by 0, but 0 divided by a number just gets us 0.
And then
So this is our slope of 0, or we can think of it as our horizontal line. Our undefined line is our vertical line. A positive slope means we're going uphill, and a negative slope means we're going downhill. Okay? And so those are our graphs that we can see, right? Positive slope, we're going up the hill as we go from left to right, downhill from left to right. We got horizontal, slope of 0, and vertical is our undefined line. We can also find slope by looking at the graph. Okay, so if we look at the graphs, we find them by using rise over run. So we can do that by looking at two intersections, right? We would find 2 points on the graph. Our first graph, E, has the points already shown for us, so we can use those points. So start on the one furthest to the left. So we have the point -1, -2. Our second point is at 2, 2. So we have a rise of 1, 2, 3, 4, and a run of 1, 2, 3. So E, we went up 4 units, and we went to the right 3 units. So our slope is 4/3.
wait, so if they didn't have like a thingy bob, like the points, you have to find the points first and then.
So yeah, so we find the points by looking for intersections. So where a line goes through 4 corners.
So the first one will be 4, -2.
So
Where it crosses?
on this one,
Yeah, 4, -2.
well, X first, so -2, 4.
-2, 4,
Mhm.
but something like that.
And then our second point could be 0, 1. So in this case, we are going down 1, 2, 3, and going across 2. And because we went down, we want that as a -3, and the run was still 2. Okay.
Wait, what you said the second one was? 0, 1? Wait, I'm so confused.
So the point on this one was -2, 4.
Yes.
Was our first point. Our second point was 0 on the x-axis, right? This is our y-axis here. And it was on 1 on the y-axis. So that's actually our y-intercept as well. Right? So we went down 3 units, and we went over 2.
Why aren't you get 0, 1 though? There's like, my bad. I see it now.
Okay? G, we have that vertical line, so it is
It's
undefined. And then H, we have a horizontal line, so its slope is 0. Okay.
This is a lot of notes. That's what I- a lot of notes. Like importance slash. Oh my God.
And then we can also find using tables. Tables are just a set of multiple points, okay? So a table is just like if we were given 2 points, but this time they're giving us 4 points, or 5 points, or 3 points, or 4 points, okay? So we can take any 2 of those points. It doesn't have to be first 2, be the first and the last, be the middle 2, it doesn't matter. So in this case, I,
10 and 40,
10 and 40,
and 20 and 20.
and 20, or
20 vision.
20. Okay. So again, we can do y2 minus y1. Right.
Sure.
40 over x2 minus x1. Simplify that down, we're going to get negative 20 over 10. So that can simplify down to negative 2.
Yes, sir.
Okay. Y'all understand how the tables work?
Sure. Wait, do we have to do the rest of them now? Or
No, these are just your notes.
Okay.
Okay.
A climber is on high.
So then let's look at our word problems. So this is where they can say rate of change. Again, we can think of it same exact thing as slope. But we're figuring it out from a word problem, not from a graph or an equation. So that's why they say rate of change. So in this case, we have a climber is on a hike. After 2 hours, he is at an altitude of 400 feet. After 6 hours, he is at an altitude of 700 feet. What is the average rate of change? So let's break this apart sentence by sentence, see if we have anything important. A climber is on a hike. Doesn't matter. I don't care what he's doing. After 2 hours, he is at an altitude of 400 feet. So he's climbed for 2 hours. Time is generally going to be our x-axis. And he is now at a height of 400 feet. So there's our first point, right? He's climbed for 2 hours. He's climbed 400 feet.
And that would be
After
700.
Yep, perfect.
All right.
After 6 hours, he's now at an elevation of 700 feet
I got
altitude.
it. And then it'd be, hold on, I'm usually thinking wrong. And then it'd be 400 minus. Wait, hold on.
We can do that.
I did y twice. I messed up the formula. 6 minus 2.
Now, if we did 400 first, we need to do the 2 first. Okay? I'll show you.
Does it matter which way though? Yeah, okay, so we should know this.
Okay.
We probably learned this last year when I didn't have teachers.
So on this one, 400 minus 700 gets me negative 300. 2 minus 6 gets me negative 4. If we divide those negative by negative, we get a positive. 300 divided by 4 is 75. If we did it the other way, we get 300 over 4. Still get 75. So it doesn't matter what point you count as your first point, which point is your second point, just as long as you use those same values first, right? So if I use my y2, make sure to use your x2, subtracted by your y1 and your x1. You use your x1 minus your x2, make sure you do the same thing with your x1 or y1 minus your y2. You get the same result. Okay. Any questions?
Wait, is this the paper we gotta do?
So the next paper is your actual homework assignment, yeah.
Hold on.